How does the bell ring? Oh, we're good.
Uh-oh.
I always get 5th and 6th.
Now everybody's spinning. Everybody on
All right, so here's the magnesium. It's an element. We've got many, many magnesium atoms, and we are going to back up your story. No, it's hydrogen gas, not poisonous. Now, this setup right here works to trap hydrogen gas because hydrogen gas is one of the least dense, if not the most lightest gases in the atmosphere. And when we mix different gases like oxygen, carbon dioxide, and hydrogen gas, the one that's the least dense will collect at the top. So I'm just using what I know about the density of matter to separate the gases based on their densities. The carbon dioxide is probably one of the heaviest gases here. So the carbon dioxide that was in here, probably from all of us exhaling, is collecting down below. Hydrogen gas being formed is rising because it's the least dense. Okay? You remember the density column with the syrup and the soap and all those things? Okay? The alcohol was the least dense of those fluids, and therefore it migrated to the top of the container. Well, you can't see it, but the hydrogen is collecting here. It's the least dense. And we're going to give it just a little bit more. And a lot of people, when they see a reaction like this, say, well, the atoms of magnesium have just been destroyed. They're gone. But they're there. They've actually combined with chlorine atoms to produce a soluble salt, magnesium chloride, which just like table salt dissolves in water. You don't know it, but those salt, magnesium chloride salt, is dissolving as soon as it forms.
Sorry.
The bubbles are hydrogen gas. Now the space shuttle in the video you saw uses thousands and thousands of gallons of liquid hydrogen. Okay? Many, many times much more than what I've got here in this flask. I'm going to give it just another minute here. All right, let's see. Volunteer. I saw your hand right up here. Got to have goggles on. Okay? Go put your backpack down.
What?
All right, so a very high percentage of the gas in here is hydrogen. And we are going to give it just a little bit of energy to start this reaction right here. Doesn't take much, because once it produces water, the energy will be used to start and continue the reaction. Kind of a chain reaction. All right, so you get to ignite the hydrogen, all right?
Fire.
Okay, I don't want a big flame here. I want to stand right about there. And I'm going to hold the flask right about here, okay? And then I want you to just slowly bring the tip of the match, it'll be burning, to the opening of the flask. Okay?
Fire. Fire pretty.
Okay, just hold it up like this. Okay, hold it right at the opening.
Dude. Science.
All right. Very good.
Yay.